B is finding the number of terms. Finding the number of terms in a sequence. Okay, so finding the number of terms in a sequence. So, for example 1, and like I said, there's only 3 of them. I want to know how many terms, how many terms are in the sequence. It's pretty much going to be standard question for what we're working on today. Okay, and if I give you 95, 99, 103, on and on and on, until 211. How many terms are in that sequence? A couple different ways you could do this. Technically, you could sit here and keep carrying out the terms. Okay, obviously this is arithmetic or geometric? Arithmetic, because it has a common difference. So since we're at this now, we might as well write it down. So this is an arithmetic what? Sequence or series? Sequence. It's kind of in the title. Okay, so you could technically carry out these terms and you could write them all down and then you could count them all up until you get to 211. Probably not the most time-effective thing to do, but you could. Okay, so first thing you want to do, decide if it's arithmetic or geometric. You know that it's arithmetic because it is adding, or because you're adding or subtracting, and the common difference here is what? Adding 4, right. Okay. Now you want to use the arithmetic sequence formula, which is a sub n equals a1 plus d times n minus 1, and we're just going to plug in, okay? I know what the last term is, so this is always your last term. I know what the first term is. I know what the common difference is. The only thing I'm solving for is the term number. I want to know what term number is 211. Because basically this is your A1, that's your A2, that's A3. This is we don't know, so it's your AN. So just plug in n minus 1 and solve. So 211 equals 95 plus 4n minus 4. Combine things, move them around, however you see fit. Subtract over, that's going to give us 120 equals 4n. Divide through, 30 equals n. So, how many terms are in the sequence? 30. That's your answer. Okay? We don't have to plug anything in. We don't have to, add due to common difference like yesterday. We're just figuring out how many terms are in the sequence. Questions on how I did that? Not too bad, right? Okay, so there are 30 terms. I'm sorry? We are going to do some that are geometric, which could be a little, well, the next one's geometric. So I'm going to use a little bit bigger paper just in case. Probably shouldn't have told you that this is geometric, but you'll figure it out eventually, okay? How many terms are in the sequence? Let's see, 81, 54, 36, continue on until we got to 64 over 9. So first things first, decide if this is arithmetic or geometric. So you always want to figure out, is there a common difference first? So to get from 81 to 54, what would you add? You would add a negative 27. Can you add negative 27 and get from 54 to 36? No. Therefore, it has to be geometric. Okay? Do we remember, how do I figure out the ratio for geometric? You probably don't know in your head. What do you multiply by to get from 81 to 54? So to find the common ratio, you take any term number, divide by the one in front of it. So obviously we can't use this one because we don't know the one in front of it. But you could use 36 and 54 or 54 and 81. Does not matter. I'm going to use 36, divide by the one in front of it, which is 54, and then reduce. How can that reduce? Keep reducing. Keep reducing. What does it reduce to eventually? Reduce however you'd like. It's going to break down eventually to 2/3. Okay, you can break down by 9, by 2, by 3, by 6, doesn't matter. Keep going, and it'll eventually break down to a ratio of 2/3. Now, which formula do you think I'm going to use? Geometric sequence formula. So geometric sequence formula is a sub n equals a1 times r to the n minus 1. So again, we know that this is your a1, that's a2, a3, this is an, because we do not know its term number, so that's what we're solving for. So 64 over 9 equals a1 of 81, ratio of 2/3 to the n minus 1 power. This is where it gets a little messy, okay? How do you move this? What do I do? Divide by 81. Okay, divide by 81, which yes works, but it's a little ugly. Divide by 81 is the same thing as what? Multiply by its reciprocal, so multiply by what? 1 over 81. Okay, so that's the same thing. This is going to go away, which is what we want. We're going to end up with 2/3 to the n minus 1. What happens all over here? We're going to have to multiply. 64 over, if you can reduce, please do, 729. Can't be reduced. So now we need to figure out if this is to the n minus 1 power. To solve for n, okay, the fraction on the left side has to be a power of what? One on the right. So let's look at this. Let's look at these separately, okay? 64 to what, or excuse me, 2 to what power equals 64? So we're going to basically make some boxes, okay? And we're going to figure this out. So 2 to what power equals 64 is 2 to the 6th. 3 to what power equals 729? Make a big guess. Guess. 6! It would have to be the same. Okay? It has to be the same. So basically, another way of writing 64 over 729 is 2/3 to the 6th power equals 2/3 to the n minus 1 power. Now, this is hopefully a little bit familiar. What do? Kind of like in logs. Drop the bases. Set these equal. 6 equals n minus 1. Move it over. 7 equals n. Therefore, there are 7 terms.
Oh, I don't like those ones.
You don't have to like them. You just have to do them. Okay? This is why this is the honors part. And regular didn't do this.
Can I switch to regular?
No switching to regular yet anymore. Okay, last one. Last one. You guys, oh, come on. You can, there's only like a couple problems like that. You will be fine, okay? I want you to find the position or find the term number basically of negative 49 in the sequence 8, 5, 2, and so on. Find the position of negative 49 in the sequence. This is basically the exact same thing as what we just did in example 1 and 2. It's just asked in a different way. So basically I'm saying 49 is what term number? So you're going to do it exactly the same. A1, A2, A3, AN, and we're searching for this term number. Sorry, negative, thank you. Sorry. So, is this arithmetic or geometric? Arithmetic. Hopefully we can just see that, okay? So it's an arithmetic sequence. What is its common difference? -3. Okay, so use the arithmetic sequence formula. AN equals A1 plus D times N minus 1. What am I going to plug in for AN? -49 equals A1 is 8. Common difference is -3 times N minus 1 and solve. -49 equals -8 minus 3N plus 3. So -49 equals, I don't know. Something like that. 11 minus 3N. It's really, I don't know. Subtract the 11, so -60 equals -3N. N equals what? 20. If you got a negative, which I might have done if I made that mistake, does that make any sense to have a negative term number? No. So if you get a negative there, it doesn't make any sense. Okay, so it is the 20th term. Or what position? It is in the 20th position. Okay? That's your homework. Or, excuse me, that's your notes. Your homework is going to be, again, that worksheet 6. You are doing numbers 17 through 25. Okay, numbers 17 through 25. That's what we're working on. We will start, well, we're going to keep going tomorrow. I forgot what we were doing. Okay, that's going to be it. Actually, I'm sorry, this is going to be 16 to 25. My bad, sorry. 16 to 25. That's it. You're done.